Good morning, good afternoon, good evening to people around the world. This is your host of the Db2Night show, Martin Hubel, IBM Gold Consultant and lifetime IBM champion. Thought I'd throw that in. I've got a special guest. Our special guest this week is Ian Bjorhovda of Extivia, lead Db2 DBA. How are you doing today, Ian?
Good, Martin. How are you?
I am fantastic. We actually have sun outside. We haven't had that all week. It's been rather dark and dreary, almost to the point of needing lights on in my south-facing office. But it's nice and sunny today. It must be because of the Db2Night show. That's all I can think of. So let me get the housekeeping out of the way here. As always, we have a Twitter feed, hashtag Db2Night, that I'll try to remember to use when I communicate with you. We have our LinkedIn group, and we also have our replays now on YouTube. So if you don't want to download things, you can go there. If you still want to download, be our guest. We still provide it, the show in WMV, MP4, and we also put up the PDF of the presentation slides when our kind presenters make those available to us. Here's our famous disclaimer, copyright 2020 DBI. We're recording it. We'll make that recording available to everyone at the end of the show. Other things, quick announcements. I now have a title for the show on the 20th of November, Adaptive Workload Management Overview and Best Practices by Dave Kalmick of the IBM Toronto Lab. And our next presentation will be Machine Learning and AI with Sheikh Kader of the Toronto Lab. And also we have Db2 or Night Show Z version shows, distributed access to Db2. Christian Malero has been doing that a version of this presentation for a number of years, and every time he updates it, there is something you want to know. So please tune in. And Dan Luxtetich will join us with Db2 on Z Index Performance Recommendations, another must-see show. So we're looking good for the fall. I'm already lining up shows for January and onwards. So we're alive and well and still having fantastic presentations. As always, we have our founding sponsor of the Db2Night show is DBI Software, and you can watch a demo and receive a Starbucks gift card if you do. If you go to the DBI site and watch the demo, they ask for your contact information, and we'll send you that. Also, our winner from last show was John Pearson of Wakefern Foods. Congratulations, he's got himself an Amazon gift certificate. And thanks to our sponsors, DBI, yours truly, Martin Hubel Consulting, and we're glad to be here and doing this show for the Db2 community. We are up to show 228 for the LUW community, and we're well over 100 now with Db2 on Z. So life is good. The show is alive and well.
How many years is that?
I think it's about 12 years. I think I went back and looked, and I've been doing this since 2012. And it was the Z show started in about 2011 or 10. And I think Scott started in 2008, and Scott left us at the end of last year or 2 years ago. I've been doing the show now as the sole moderator for a couple of years, and we've been doing still the same. I still speak LUW as well as Z, so I'm kind of the ideal guy to do both shows, and we continue to enjoy being here. It's an interesting way to spend my Friday mornings. And it's just great with the feedback I get from emails and other folks when I see them at conferences. So we're still having fun. Now, iDoug is another sponsor of the show. They help us out. Occasionally, they even give us a badge to give away to their upcoming conferences. And certainly, we have another virtual conference planned for next summer. With the COVID situation, they had to postponed Dallas and then moved into a virtual format, and they're planning for that now. My understanding is that the people over in Europe have rescheduled to be in Edinburgh next fall in October, and they're still planning for face-to-face. But of course, we're waiting on a number of things from public health authorities before that can really be finalized. But for now, they're looking for speakers, and here's a slide advertising that. No dates on that, as you notice, for the conference itself, but I believe they pre-record them. So from a presenting point of view, you can pre-record using Zoom. They'll edit it, make sure it looks nice and professional, and then they'll make that available on various dates. The other part of that is on this slide. October 30th is the date they would like to have things in by, which is a week today. So if you've got a topic in mind, there are some great ideas there. That's mainly what they're looking for, but I'm sure they'll take them in various formats. You have a choice now of 30, 60, or 120 minutes, and that's fantastic. So we hope that conference is again successful. It's interesting when you're presenting and you're in a room by yourself. You know, if you like audience interaction, that takes a little while to get used to when you're doing it remote. But hey, I just taught a course remote this week, and it was a great experience to be able to do something, and also doing virtual when it's not going to see friends at a conference was a good way for me to save an awful lot of time in airports. And believe me, I've seen enough of airports through the years. Now we're into our polling section, and we have, I'll just pop these out so I can see them a little better. And we'll ask you the standard questions we normally ask to start off. Here's our first one on what version of DB2 are you running? And you can click the ones you are and submit that. And after about 30 seconds, I'll close that and we'll move on to the next show. Thanks for voting. Got 83% voting. That's probably enough. So let's close that and share the results. And we're showing now that 50% of our audience is on 11.5 and 80% is on 11.1. Of course, there are multiple votes from some folks, including myself. So we'll hide that and move on and do the next poll. What other DBMSs are you running besides Db2 LUW? I'm assuming you're running Db2 LUW, or you would not be here. Now, I put a category in there for other mainframe DBMSs, that might be IDMS, IMS, Model 204. Came across a Model 204 database the other day.
Can you still get Oracle on the mainframe?
You know, they stopped that some time ago. They just weren't making any money at it. They managed to, I believe the high watermark for the number of licenses they had at one point was 30. And at the time, IBM had 10,000. So they realized that they should, certain things that they just couldn't do. And so they stopped doing that. So here we see an awful lot of our audience likes to run DB2 on Z, and we have Oracle and SQL Server in there as well. So we'll hide that up and move on to the open source DBMSs. And it's interesting to see which DBMSs people are running. Again, a lot of people have voted already. Thanks for voting quickly. Moves the show along. And we see here we've got Mongo, MySQL. I came across another one the other day called Cockroach DB. And I have no idea why somebody would name a product Cockroach.
That has actually interest to the DB2 community, because Adam Storm, who was the original developer of STMM, recently moved over to Cockroach to be their director of engineering. Exactly. That was the guy I was thinking of. I'm Facebook friends with him, and I sent him a howdy, and I didn't hear that. Ironically, he used to go and listen to the brass band I played in with his wife. His wife worked with somebody at a hospital where
They were coworkers, and so they would come along and listen to our brass band, which was kind of unique because very few people listen to brass bands. The audiences are not all that large. So how do people run DB2? This is kind of pertinent to what we're doing today. And we're seeing that about 35 seconds, most people have had a chance to vote. I'll share that. We still have people liking to do bare metal, and I got to confess I do that myself. But it'll be interesting to see on the local container and cloud hosted what's going on there. And we'll hide that. And that should make my screen visible again, which it is. So at this point, I will move my screen forward. And Ian, you're up. And if you could, please, I'll make you the presenter. If you could find a spot in your in the schedule of your presentation to allow me to do display a video for DBI, they would be most grateful. And I see your screen is looking good. You're in presentation mode, so please take it away. In the meantime, I'll be watching the question and answer queue, and if any questions come in, I'll unmute myself and ask those of you. So here we go.
Thanks, Martin. Good morning, everybody. Thank you for joining us today to talk a little bit about Docker and how you can integrate Docker into your DB2 environment. So a little bit about what we're going to talk about today. I'll go over a brief introduction of what Docker is and what containers are for those of you who are not too familiar with it. And then we'll talk about 4 different recipes for how you can use Docker with DB2 to get up and running successfully. So first of all, for those of you who don't know what a container is a way to run an application in a shared operating system where it is fenced off from the rest of the operating system. It's a technology similar to, it's a virtualization technology, but it's not the same as running virtual machines where you are running an entire operating system in a virtual environment. In this case, you're just virtualizing the application that you want to run. There are a number of different container technologies. Some of them have been around for many years. In Linux, which is pertinent to the discussion today, Linux has containers called using a technology called LXC. AIX has had workload partitions for a number of years, and Solaris, I think, has had zones for even longer than AIX and Linux. These are all something that come from a function that came out of BSD even longer ago called jails. So if we want to compare containers against virtual machines, you can look at this diagram that I pulled from an NIST publication, and it really kind of points out the differences. When you have a virtual machine, which is shown on the left-hand side, you can see in that stack that there's a hypervisor sitting on top of the host operating system. But then on top of that hypervisor, you have a guest operating system for each unique virtual machine. So that's an entire operating system, an entire kernel, everything is running. So there's a fair amount of overhead to start up each virtual machine. If you compare that to the stack on the right, on your hardware, you have one operating system kernel running, and then on top of that, you have a daemon, and the container daemon just provides a way to control the containers. It doesn't. This picture is a little bit inaccurate because that daemon doesn't actually sit between the host operating system and the containers. It just is there for providing messages to start and stop containers and the like. But then inside each container, all you really have are the binaries and libraries that are necessary for the container, or excuse me, for the application that runs in that container. The containers rely on those features that are in the kernel of the operating system to provide isolation from each other and from the host operating system. And so one way to illustrate this is to think about containers and virtual machines as something more concrete in the real world. And if you think about it, if you think about a virtual machine, I like to think about that as a house, whereas I think about a container more as like an apartment. And so in a house, you have dedicated infrastructure. You have one foundation per house. The structure is unique per house. The connections to utilities and everything are all unique to each house. And typically you would have just, one family living in a single house. Whereas if you compare that to a container, it's much more like an apartment building. And in that apartment building, all the infrastructure is shared. For the entire apartment building, there's one connection to electric, one connection to the plumbing. There's shared heating and cooling that goes throughout the entire building. And there are many apartment units inside of an apartment building. And so that's much more like a container where you have the shared operating system that applies for all the containers. And the network and the storage and everything like that is all provided by one host operating system. Moving on to Docker. So Docker is a technology. It is an application that is built entirely on Linux. It's been around for 7, almost 8 years now, and it's an open source project that you can download from docker.com. There are enterprise editions of it that, as you would imagine in how open source software is developed these days, you can get a free version. There's also an enterprise version that has support and more features. One of the things that's interesting about Docker is, in spite of the fact that it's developed entirely for Linux and depends on the Linux kernel, there has been a lot of work from Docker's perspective to create native Docker containers that run on Windows. So from a platform perspective, when I show here that it runs on Linux, Windows, Mac, and even on the mainframe on ZOS, all of those by default are running a Linux environment under the operating system. So Linux, obviously you're running Linux, but on Windows to run Docker, you're actually running a small Linux VM that runs the Docker engine. Likewise for Mac OS, on ZOS you're running Z-Linux, and so you're just running Docker containers within that Z-Linux environment. Cloud providers also provide Docker environments that you can run on. So all the major cloud providers, whether it's Amazon or IBM or Microsoft, have the ability to execute containers. So let's talk a little bit about how storage works when you have a container. When you start out a container, you start from an image, and an image is like a frozen version of the file system. And you kind of want to think about it somewhat like a layer cake, where each layer has a set of changes that when you put them together, you end up with a final picture of what the file system looks like. So it's called a union file system in an image. So if we look at this picture here on the right, we can look at how a particular Docker image is built. You start out with one layer. The first layer in this case would be CentOS. It's just some of the base libraries that you need for your container. That would be things like the C library, basic commands like the shell, ls, that kind of stuff. Then on top of that, you would have another layer, in this case, which would be the prerequisites for installing DB2. That may be libpam or some of the 32-bit libraries that you may have run into in installing or running DB2 prereq check. And then finally, you'll have one more layer, which is the actual DB2 installation. And that's the files that typically would go into opt IBM DB2. Now, when you start a container, you take this image, and then Docker creates a small writable layer that sits on top of all of these other layers, which you can actually make changes to files. You make a change to a file, even though it's frozen in the images below. The way that the Union file system works is it makes a copy of that file in that writable layer that you can then edit. Now, talking about this small writable layer, if you're going to be making a lot of changes or having a lot of files inside your container, typically you would want to have those reside outside of the container. You typically want to try to have your container have as few changes as possible, and the way that you do that is by using bind mounts. And that allows you to share a directory that exists on the host operating system into the container. So in this illustration, I have a directory called /home/idbjorh/db2fs, and I want to mount that into the container, and I want to make that available as a directory inside the container called /database. And so what that does, that means that any changes to files in /database are not happening in that small writable layer. Those changes are actually occurring in the file system outside of the container. And as you can imagine, that allows you to have some persistence of data so that if a container goes away, you don't lose the data that was changed inside the container. So that's a brief introduction to containers and Docker. Given the poll results, it said there was about a quarter of the audience today has been running in local containers, so hopefully that's not a lot of new information for you. So let's get on to how you want to use Docker or leverage Docker to make your life running DB2 simpler. And the first recipe that I'll give you is how to simplify applying Fixpacks or performing DB2 upgrades. So when you're going to do a Fixpack or an upgrade, it's often a fairly lengthy process, right? You need to plan how long is it going to take, who needs to be involved, how are you going to install the code, what are you going to do about cleaning up old versions of code that are on the box, how do you handle rollbacks if you need to, etc. And then also you need to make plans for doing the outage. Typically when you're installing a Fixpack or doing an upgrade, it's a somewhat lengthy outage. And I say somewhat meaning, it could be 15 minutes, it could be 45 minutes, depending on your requirements. And it's also can be complicated because there are a number of steps that you need to do in order to perform the install and then complete the tasks after the upgrade. And if you think about, in production, we as DBAs will often do this, and we've done this many times, so it's not particularly, it's not an impossible task, let's say. But if you ask your developers to go and deploy a new version of DB2 on their development environment or on their workstations, that's a little bit more of a challenge. And is that something that they can do successfully every time that there's a change to DB2? But Docker can help you make that easier. So as I mentioned before, in an ideal world, a Docker container will really only have the required binaries and libraries that you need and any dependencies inside that container. So if you think about your DB2 system, what would typically be inside of a Docker image? And so from system binaries, that would be files like, for example, user bin and user lib. And the application binaries would be files like in/opt IBM DB2, perhaps in /var/db2, that's where the global registry is hosted. And some of you may also think about the instance owner home directory. I would argue that the instance owner home directory is not really the right place for the running that inside the container is not the right place for it, because there's a lot of files that get changed inside the instance owner home directory. So that's probably something that should live outside of your container in a bind mount. So things to think about with containers is you have to consider them as ephemeral. They exist for some period of time. You don't perform software updates inside of a container. So you don't apply operating system patches, you don't apply Fixpacks to a container. All of those things happen inside in a brand new image. So you can build images if you need to apply operating system fixes, if there are patches, you would build a new image that has those fixes incorporated into the image. Likewise, if you're rolling out a new version or a new Fixpack of Db2, you would deploy that in a new image, not perform that upgrade in an existing running container. So what does that look like from a Db2 perspective? How do I take a running container and upgrade it? So if I run the docker ps command, it will show me the running containers on my system. And you can see here, I have this version 11.1.3.3 container that's been running for a number of months. And I'll do a little bit of inspection to see what images do I have available locally on my machine. And you can see here I have a whole bunch of different versions of Db2. I'm going to, in this case, choose to upgrade to the latest that I have, which is 11.1.4.4. If I dig a little bit in, I want to just check what's going on with the existing container, gather a little bit of information so that when I do the upgrade, I have the information that I need. So I'll verify what version of Db2 is running by running the Db2 level inside the container. I will check to see what kind of mounts, what bind mounts exist in the container. In this case, you can see I have that /home/idbjorh/db2fs directory mounted in the container as /database. And then finally, I'm going to shut down this Docker container. And at this point, Db2 becomes unavailable. To upgrade, since I have the new images that I showed a couple slides ago, I'm just going to instantiate a new container with a new Docker run command. This is very similar to what you did in order to start your previous container. Just the difference is I will give the container a unique name, shown here. I will point that bind mount again to the new container. And then finally, I will supply the name of the image that I want to run. In this case, I'm running the 11.1.4.4 container. So I just run this Docker run command. It fires up the new container. And now I can check to see what version of Db2 is running inside this container. And you can see that, boom, I'm running Db2 11.1 mod 4, Fixpack 4. And the total effort required to do that was, or the total outage was, under 2 minutes. If you're fast, you could probably do that in about 45 seconds. Now you may be thinking there are a few other steps. Applying a Fixpack isn't as simple as just starting Db2 running on the new version. You do have to do things like run Db2 update version 11.1 and perhaps rebind images, and I'll get to that in just a second. You do need to plan, however, a couple of things. You want to make sure that you don't name the container the same as you had before, or if you want to retain the same container name, you'd want to remove the old container. You can use Docker RM to do that. And then likewise, you probably want to plan to take a backup before doing the upgrade. Again, just starting Db2 with a new Fixpack without doing any of the changes like Db2 update version 11.1 or binding the CLI utilities, you haven't made any changes to the database, but for backup purposes, having that backup can be valuable. Now you'll notice that nowhere in here did I mention running Db2 update. And that's because the container itself takes care of doing that when you instantiate or the image takes care of that when you instantiate a new container. So when I executed the docker run command, Db2 automatically performed that Db2 update on the instance for me. And so that covers how to perform an upgrade with Db2. I will mention that currently the images that IBM provides do not, or they do contain the ability to perform the Db2 update. They do not have the ability within the image natively to do a Db2 upgrade. So to move from, say, Db2 11.1 to Db2 11.5 will require a little bit of extra work for you. But in talking to some of the folks in the Toronto labs, I understand that's something that they are working on, how to make the version upgrades more seamless. So moving on to recipe number 2, let's talk about how you can extend an existing container or an existing image. And that's a case where if I take a look at a Db2 image, I might like it. It might do almost everything I want, but after you run it for a little while, you may start to think, there's just these couple of things that I'd like the container to do that I don't want to have to do manually. I wish I could bake that into the image. And so let's see how we can do that. The images that IBM provides, I've found to be remarkably good starting points. And so my goal is, for myself, is to extend those containers. Some of the improvements that I'd like to see, though, are, and the big one is they take a long time to start. And this is sometimes a surprise to people who are new to Docker, is that when you issue the docker run command for a Db2 image, it may take 90 seconds to have a fully functioning Db2 database. Db2, the container, when it starts, will do a number of stops, Db2 starts and Db2 stops, and it takes a little while. The other thing that I would like to see the container do is activate the database rather than leaving it deactivated. So what can I do to improve those two things? Well, I can create a brand new image. I can just say, you know what, I don't like IBM's image. I'm going to just create a custom image all by myself. Or I can extend that existing image and enhance it. So if we compare those, the advantage to building an image completely from scratch is that you have total control. You can do whatever. You have the power to do whatever you want and make whatever changes you want in your container. The downsides of that, of course, are building a container from scratch is very complicated. It takes a lot of time, a lot of expertise, a lot more expertise than just issuing a docker run command. And you'll probably want to do a fair amount of testing to make sure that your container is running well and works. Over the years, just looking at the images that IBM have provided, there have been a lot of changes, a lot of improvements as IBM has learned and gotten feedback from customers in the field about how they can run the container better. So that's what you'll have to go through that same phase if you build your own container of build a container, build an image, run it as a container, learn what you need to improve, and then iterate. Now, if we compare the idea of creating an image from scratch with just extending an existing image, The advantage here is that you don't have to reinvent the wheel. You're taking a container or an image that already exists and then just tweaking it to meet your needs. The downsides of that, however, are that now you need to maintain your own images yourself instead of just relying on third party. And you're also completely dependent on those upstream images from you for any changes. So for example, if I'm building a container off of something that IBM provides, IBM may release a Fixpack, but if they take a month to update the image that has the new Fixpack with security fixes in it, my containers are, if they're dependent on IBM's containers, or excuse me, images, I can't make those changes, or I can't roll out those updates until I can get the updated source image. And then the last downside to extending an existing container is that now you also have to take responsibility for how to deploy the image. And that's would mean running perhaps your own Docker registry internally within your company. You wouldn't be relying on Docker Hub unless you wanted to publish your image to Docker Hub, which many people may not want to do, depending on the level of customization that they apply to the image. So for this example, I'm just going to extend, as we talked about, I'm going to extend the existing container, and really I want to create a script to activate the database. So this is a simple script, just a few lines that will look at the container, look at the list of databases within the container, and activate them when the container starts. You can see I'm reading this file. Again, this is a file that is created and maintained by the IBM image. And what's contained in that file is basically some information with IP address, the port number, and in this case, most relevant to this discussion are the list of databases that exist within that container. So I'm going to get this list of databases and iterate through it and perform an activate database on each one of those databases. Next, what I've found is that the biggest part that slows down the start of IBM's containers is the fact that by default, they always start the text search service. In my case, I'm not using the text search service, so I can just eliminate that. And by making a simple change to this script, by adding a variable that you specify at container runtime to identify whether you want the text search service or not, I can avoid that long startup process. So what does it look like to actually extend the existing image? In Docker, to build a container, to build an image, you create what's called a Docker file, which is just a simple text file that looks like this. I'm going to specify a from line, which is an instruction to tell Docker what image to start building from. So in this case, I'm going to specify that I'm going to use the IBM 11.1 mod 4 Fixpack 4 container, or excuse me, image. And then I'm just going to run a command to create the var custom directory. That's something that is unique to IBM's containers. Their startup scripts do have the ability to, or they will look for the var custom file system and execute any scripts that they find in that directory. That's something that's built into IBM's images out of the box. And is intended specifically for what we're doing here. So then what I'm going to do in this Docker file is I specify 3 copy commands, which copies files from the host into the image during the build phase. The first 2 files are the files that contain the changes to prevent the startup of the text search service. And the third file here is the script I showed you on the previous slide to find and activate the databases in the container when it starts. Now, to build a new image, I just run this docker build command, and I specify that with the -T option, I specify the name of the image that I'm going to give it. So I'm just going to name it custom and give it a version number 11.1.4.4. And when I run this Docker build command, it doesn't take very long in this case because I'm not making very many changes. And it will basically, you can see the steps that get run where it's copying the files, making the directory, etc. And then it tags the image. So if I run Docker images command now to see what images exist on my machine, now you'll see that I have this on the first line here, the custom image that I just created. So now to start my container, I'm going to add one environment variable shown in red here, the -E text search equals false, which will instruct my container to not start the text search service. And then the name of the image I provide now is the name that I gave when I built the image. So instead of that long Docker store name, I'm just going to give custom and then 11.1.4.4. So this starts up the container. And now when I look at what databases are active within the container, you can see that in this case, testDB is activated when the container starts. So advantages to this are, again, significantly faster start time, which was one of my goals, and now my databases are activated. And when I compare the time that it took to start a container using the vanilla image that IBM provided to the version or the custom image that I built based on that container, you can see I reduced my startup time from a little over 1.5 minutes down to just over 15 seconds. So this meets my goals for having a Db2 container that starts better and is more usable. And with that, that gets me to the end of recipe number 2. Martin, I don't know if you want to take a break now to do your ad.
Absolutely, that'd be good. That's a great time. Let me just get my. I need to, I guess, take over control from you here. Just let me grab that. And there we are. What does this button do? There we are. There we are. And let me put this up. And I just need to pull that back over here. Start this up, make sure I get the volumes correct.
Hi everyone, thank you for coming to watch the Db2Night show. Today I'm going to show you the new DBI web suite. I'm going to show you just the part about dashboard short. So when you log on to the tool, you see a dashboard. The dashboard shows you information about all the databases that you are currently monitoring. As you can see here, I have 6 databases installed on one database, one instance, in one server. You can see here the DBI score that we calculate for each database. The higher the score, the better performing the database is. So you can very quickly see I have a very low score, very high score, and on average, I am doing okay on this. I have worst performing databases, best performing databases. I have the highest transaction rates, CPU, memory, and so on. I can dive into any of those databases and look at things in detail. This seems to be low, so I'll go in there. Now I can see the dashboard for that database. I can see different metrics. I have a timeline here that I can move around and look at different times. I can make the window smaller or larger, so I can look at things in more detail. I can also take any of those charts. I can see here you have CPU usage for percentage busy, percentage by the user, memory usage, memory free, and so on. So I can also go and dive, when I see some odd things, I can go and dive into the data more and see things in more detail, but to take something more interesting in video. So you can see here at the top, you can see any changes on the chart. When you hover over any of those points, you can also see if there are any changes. You can see all the changes listed. If there's something have changed in the database, you can see the different metrics, and you can zoom in, zoom out, and see any patterns that look odd. Like in here, this looks odd, so you can click on it and investigate it some more. You can add a lot more metrics. You can go in here and choose any metrics you'd like, and these will be added to the chart automatically. And so you can compare them to each other in a very nice and concise way. And so this will help you detect patterns and then go in and look at the statistics. Next time, we'll show you more details how to look at the statistics and methodology. Thank you for watching.
All right, let me pass control back to you, Ian. And
All right.
Thanks for watching, and now you're back to being the presenter. As soon as you click the button.
Okay, thanks, Martin. Moving on, the third recipe we're going to talk about is how to deal with maintenance jobs inside of the database. So if I look at a container running DB2 and I look at what's in the cron tab, you'll see just running the cron tab command, I get nothing. Get command is not found. And if I go and look on the machine to see if cron is even installed, you'll see that it's not. So how am I going to run any commands? How am I going to schedule any commands to run inside of the container? And that's the challenge, right? Because a container doesn't run other processes, or typically doesn't run any other processes besides what your application is. So that means that you don't have cron D, you don't have NTPD, or even ATD, or anything like that. Now, it is possible to install cron, and so that you could schedule jobs using that, but that kind of violates the spirit of having only the minimum applications running inside your container. So what other options do we have? Well, there's really three that come to mind immediately. There are other options, but let's just talk about these three today. The automatic task scheduler is a feature that's built into DB2. You enable it by setting the Db2 ATS enable registry variable. And you control jobs using a bunch of different stored procedures like admin task add, admin task update, or admin task remove. The challenge is that it can only run stored procedures, and you have limited notification options if those jobs fails, or if the jobs fail. And finally, one of the challenges is that jobs are only executed if your database is activated. If it is, if the database is not activated, those jobs will not run. So if I've set Db2 ATS enable to yes, what does it look like to add a task? Now, what's interesting about the automatic task scheduler is you specify jobs in a syntax that's somewhat similar to cron. You can see here on the fifth line, I don't know if I can highlight, but on the fifth line where it shows 513 star star star, that looks very much like cron syntax. So that's specifying a job that runs at 1:05 p.m. In this case, I'm going to run the stored procedure to run admin command and do an online backup of a database. Now, if I want to see what jobs are scheduled, I can look at a table called admin task list or a view in the systools schema. And the syntax shown here will give you an output that looks something similar to what you get if you run cron tab-L. So in this case, you can see I cheated a little bit and have multiple lines of output just to simplify the output. But you can see I've got two jobs, one job to perform admin command, and then a separate stored procedure that I wrote to perform run stats. Now, if I want to check the status of the jobs that I have to see when they've run and if they've been successful, I can query the systools.admin tasks status view. And this is what it looks like. It shows you the tasks, the task names you provide when you create them. And you can see begin and end times, as well as the SQL code for the job to say whether it was successful or not when it ran. In this case, obviously, SQL code of 0 is a successful completion. Db2 ATS, I don't run into it very often. I've seen more problems with it, and I find that most shops that I've been involved in have tended to rely on cron instead of the admin task scheduler. So let's look at ways that we could actually try and use cron with Docker. So as you can imagine, Docker containers are running on a host, and that host typically will have cron on it. So you could schedule cron jobs on the host itself. Again, using cron tab, the way to run a job inside a container is just to use a docker exec command. But the problem is that if you do this, you're creating this dependency between the container running on the specific host. So if for some reason your container is moved to a different host because of system maintenance or whatever, you have to then worry about the dependencies between the host and the container for those scheduled jobs. So this is what it looks like to run a command inside a container. I'm going to run this docker exec command, specify the container name, and then the command that I want to run. So su minus db2 inst1 -c, and then the command line that will get executed inside of the container. As you can expect, you will create normal cron entries again on the host. The third option is to use a feature that not everyone is aware of that Docker has, which is the ability for Docker to talk to remote Docker daemons. Docker does have the ability. It's a client-server model. So when you run the Docker command, that's the client. It can talk to Docker daemons running on other hosts, remote hosts. And that gives you some interesting possibilities. However, when you install Docker, by default, it doesn't get configured to listen on a TCP IP port. By default, it only listens in a socket on the local host. So you need to make a change to how the Docker daemon starts. And on this slide, I'm showing you how to do that. You edit the Docker service, and basically you're adding a this -h TCP and the host, the IP address and port number that Docker will listen on. By doing that, then I can tell system control to reload the daemon to reread the configuration file, and then restart the Docker daemon. And now Docker will listen on that IP address and port number for incoming commands from Docker clients, remote Docker clients. Now, I do want to point out that the example that I'm showing here is using an unencrypted port. There's no SSL connectivity between the client and the host in this case. It is possible to have Docker's daemon listen and use SSL so that the communications are encrypted, but I'll leave that as an exercise to the reader or the listener or watcher. Now, to show you how this works, if I'm on my client machine and I just run docker ps, I can see that there's no containers running on the local machine. However, if I set the Docker host environment variable to the IP address of the server, of the remote Docker server, now when I run docker ps, I can see that there are containers running. So it's controlled by this environment variable, and the Docker client tool, the Docker command itself, depends on that environment variable to know which Docker machine or Docker server it's going to talk to. And what's kind of cool about this is when I'm pointed at a remote host, now I can execute a command and log into that remote container. So I'm just going to start a command on that remote container to SU to the instance owner. Now that's why I pointed out on the previous slide why you want to make sure that this is an encrypted connection, because now someone could just sniff the network with the configuration I've shown and see these commands and perhaps database data flowing over the wire. So now on my client, I can set up cron entries to have the Docker client talk to multiple remote servers and schedule jobs to run on those. So in this cron set of cron entries, I have commands running on 2 different servers. The first is on this IP address ending in .12, and I'm going to specify a job to perform run stats. And then I have a second job that's running on a different host. This was the IP address ending in .14 to do that same job. So the advantage here is that now I have one centralized machine, this client machine, which now is responsible for running and scheduling jobs on multiple containers on multiple machines. So it's a single point. There's one cron that's available across your entire Docker deployment. So if we compare between the 3 options here, you have centralized scheduling, which is available only using the client method. If you want to use shell scripts to run commands inside your containers, you would have to use either stuff scheduled on the host itself or with a remote client. Offline backups, obviously you can't do that with the automatic task scheduler, just because you can't take an offline backup of a database you're connected to. And then finally, perhaps this is a negative, is it requires access to the host itself, right? The Docker host, you have to be able to log into the host where the container is running. So that's perhaps a negative check mark, which is why I show it in red here. So that covers how to automate maintenance. As I mentioned, there are other ways to do this, other possibilities, but these are just a few that I wanted to present today. The last item is how to handle authentication within a Docker container. So for those of you who remember back in the 90s, good old salt and pepper, how would you handle users in your container? The first thing I would do is I would go and look at what is in etc password, what users are defined. But if I look inside the images that IBM provides, there's only 2 users defined in those containers, the instance owner and the fenced user. And I don't know about you, but if I see applications running as the instance owner, I start to get crazy. And it sets off all kinds of security alarm bells if there are applications that require the instance owner in order to run. So what can we do about that? Well, I can add users to each container by connecting to the container and then issuing the user add and password commands. Or if I'm creating a custom image, I could add additional run commands into my Docker file to perform those same user add commands. Or perhaps the most logical option would be to leverage an external authentication method, or LDAP. And that's what we'll talk about, this last option in this section. But just for your edification, here's how you would add users to an existing container by running the docker exec command on the running container, and then issuing the password command to set the password up for that user. Likewise, with a Docker file, you can see this Docker file looks almost identical to what I showed in the previous recipe, with the exception of I'm adding this run command to add 3 different users into the image. Now, I typically wouldn't like to set the passwords in the image. I would much rather set those passwords at runtime when the container is started. So that's something that you would have to remember to do after you run the container, to go and update the passwords for those application users after or at runtime. And then moving on to LDAP as an authentication, there's 2 ways to deal with LDAP with DB2. Many of you are familiar with the LDAP security plugins that IBM provides. There's one for user authentication and a second one for group membership, or verifying group membership from the LDAP server. But more commonly now, people want to run transparent LDAP with DB2 because it makes life much easier. However, when you're running a Docker container, again, if we go back to that principle of not having any daemons running inside your container other than what you absolutely need, that would preclude you from running transparent LDAP, because you wouldn't have the SSSD daemon that Red Hat uses for managing LDAP security at the OS level. So let's look at how we would do the LDAP security plugins in a Docker container. So since this is a Docker presentation and I need a Docker, or I need an LDAP server, I'm just going to find a Docker image on Docker Hub that's running OpenLDAP, and I'll just pull that image down and I can use that. So to define users in LDAP, you typically use files that are called LDIF files, where it's just text files where you provide the specifications for the users that get defined in LDAP. So in this case, you can see I'm specifying 2 different users here. Excuse me, I'm specifying 2 different classes. I'm just defining a users class and a groups class. And then here in the users.ldif file is where I'm actually defining the users. So the DN is the fully distinguished name. So it's the username is db2inst1, but the fully distinguished name you can see is quite a bit longer. And I can define a second user for the fenced user ID as well. Now these are the 2 required IDs in order to get DB2 running. So I'm just going to define those here. And then I'm going to define groups for my container or for my environment with this groups.ldif file. I'm going to define a group called db2I-ADM1, which is I'm going to use for sysadm. And I'm going to define a group called db2F-ADM1, which is the primary group for the fenced user. You can see here that the instance owner group, the db2I-ADM group, has 2 unique members, both the instance owner and a second user that is my own user ID. Now, to tell the container, or to prep for the container, I'm going to concatenate all 3 of those files into a single file called db2.ldif. Again, because they're text files, you can do this. And then I'm going to provide that file to the container when I run it. So I'm going to step through this docker run command. I'm going to give the name of the container LDAP service. I'm going to specify a few environment variables to define a read-only user. So that's a user that can only perform queries to perform validation. That will become useful in a minute. And you see here, I'm giving the host name of LDAP service. That's the host name inside the container. Next, I'm going to actually mount this file as a file. I'm going to bind mount that file, that db2.ldif file, as a file inside the container. And you can see here it's a fairly long path, but that's the path that the open LDAP container will read when it starts up. Then I'm going to just give a couple of last commands. The -- copy service is an option that you specify for this open LDAP container. And now the container will start, and we'll have those users that I defined in those three files, the ou.ldif, users.ldif, and groups.ldif. Those will be defined to the LDAP server. So at this point now I can start up a Db2 container, and I just need to add a couple of things to this, or I just want to point out a couple of options that I provide in this Docker run command. The -link option here allows me to define a link between another container and a host name within this container. So if you remember from the previous slide, I gave the container a name called LDAP service, and I want to define LDAP host within the Db2 container to be pointing at that LDAP service container. The advantage of doing this link option here is that I don't need to know the IP address of the LDAP service container. If that LDAP service container restarts and ends up with a different IP address, this container will still be able to reach it because it is mapping the container to a host name in the etc hosts file within the Db2 container. So now that will start up this container, and now I'm ready to make a couple of modifications to the LDAP security.ini file that the LDAP plugins read in order to know how to talk to the LDAP server. So I need to, in that file, I'll make a copy of the sample file, and I'll make the following modifications. I will set LDAP host to be the value that I specified in the -link option. So in that case, I'm using LDAP host and the port number 389. I will specify the base distinguished name for users so that Db2 knows how to find users. Likewise, I'll tell Db2 what is the object class for groups, so it knows how to find groups, the base distinguished name for groups, the attribute to look in for a group to see what are the members of the group. I'm going to specify the base, this is the username that Db2 will use when it connects to the LDAP server. It's using that LDAP query user, which again is that read-only user we defined. And then finally the password for that user. Now, again, I'll point out that having the username and password hard-coded into that IBM LDAP security.ini file isn't always the best. But that's why we have this read-only user, so that we can limit what that user can do. Once we've done that, we're now ready to tell Db2 to use the plugins. So we're going to update the database manager configuration to set both the ServCon PW plugin and group plugin options to point at the LDAP plugins. And we're ready to stop and start Db2. And at this point, when Db2 starts up, it will start making calls to the LDAP server to perform that validation. And if you've made a mistake and you haven't done something correctly, even your start won't function, because Db2 won't be able to authenticate that the user, Db2 inst1, it won't be able to validate that user that has sysadmin privileges with the LDAP server. In this case, everything was done properly, so Db2 starts up just fine. Now, making all these changes by editing text files and stopping and starting the LDAP server isn't always the easiest. There's an open source project called PHP LDAP admin that provides a web-based interface for managing an LDAP server. Not surprisingly, there's a Docker container that you can run, shown here, to start that, so you can add users that way and modify your users that way. But you can create additional users with LDAP files, as you would imagine. So I'm going to add a user named Ricky Bobby into this this container. So I'm going to add these entries into this file called user.ldif. And then I'm going to use an LDAP command to add the user to the LDAP server. So first I'm going to set a password. Slap password will just output the encrypted password to the command line, and I'll just append that output with a specific format into that user.ldif file I just showed you. And then I will copy the file onto the container where LDAP is running, and then perform an LDAP add command in order to read in the contents of that file and add it to the LDAP server. As you can see, it's significantly easier to do this with a web-based interface than going through these multiple steps to create a file, create the password, copy the file to the container, to the LDAP server container, and then issue commands on the LDAP server container. But it is possible. And that gets to the end of recipe number 4 of how to handle authentication within your containers. Next, we move on. That's the end of my presentation as well. So if there are any questions, I would be happy to try and answer anything that you may want to know.
I'm looking at the queue here, Ian, and there's no questions. I thought it was an absolutely clear and great presentation. Just on the ATS, though, the Automated Task Scheduler, the only time I've actually found it useful at all was in the Windows environment. I had a situation where we had to set up things, and it was an easy schedule to use within Windows to talk to another machine.
Yeah, I don't know, my distaste for the automatic task scheduler extends even onto Windows, and I've resorted to using Windows Task Scheduler.
Well, I didn't find that one. We ended up using the ATS, and we were doing a whole bunch of loads by having a bunch of stored procedures that set up load jobs, and then we encompassed those in another stored procedure that ran the loads in a certain schedule on certain days. And that worked out for us with one client. But I would put that about 6 or 7 years ago. I haven't touched it in a long time since. But
yeah.
All right, with that in mind, I'm going to take over control again. And we'll wrap up the show, and thank you profusely again for doing this great presentation, Ian. It worked out fantastic. I think this will be one that people will be downloading. Of course, we have an awful lot of people later that download the Db2Night show. We're well over 2 million downloads of past shows. So we expect that to happen with your show again, just because the information is so great. So with that, it's about 12:15 Eastern time here, which is lunchtime. We'll let people get to lunch. I will thank you once again, and we will see you in another couple of weeks for a Db2 ZOS show. And again, thanks for attending, and we'll see you again soon, and then on November 20th for the next Db2 LUW show. Bye-bye all.
Thanks everybody.
Again,
Thanks, Martin.
Thanks. Bye-bye.